Y17 is always 17. Oh my goodness. So we add, multiply by, okay. So the result is a sequence of possibilities. General adoption of a new line. No new line characters. Rn becomes, so we also do the ASCII character of equal sign. Okay. Let's see. Just one line. Let's go over here. Let's sample. Okay. So let's see. Okay, so we have this, which is stripped in the let's see. We don't want any of this. Okay, all right. So basically, data, we can use reduce really, but it's okay. What I'm gonna do is compute this thing right here. Okay. All right. Fine. Just word. It's gonna split the word. I'm gonna get reduce. And we're gonna do just reduce initial value 0. And what we want to do is we're going to increase the thing by the ASCII code. So it's like a car code. So how do I do that? Right, so let's see. Car at just like something like this. Okay. Car code at. Right, so plus b dot car code at. So we add, and then we multiply by 17, right? 17, and then we mod out what? 17 mod 256. Okay. So what is A on the word hash? This. It's not 52. So that's 52. Okay, so now we have data. So now we want to reduce the by applying hash a plus a b answer with 0. Then this that's the answer. Okay, we stopped. So let's see. Let's print out everything. So instead of reduce, let's map AU, print this, see what happens. 30, 253, oh, that's right. Oh, I just didn't do it on my example. Inputs. Okay, there we go. 23 seconds. All right, we can wait, but then what's next, right? What's next? 23 seconds left, 12 seconds. So, yeah. So basically, we just reduce the nice application of reduction, really array language thinking. Go. Oh my goodness. You convince the remainder to bring your page, the page conference, working improvement. The book goes on students. Boxes, each box, line slots. One through 9. Hash map. Okay. Equals on a dash sign. If it's dash sign, go to the relevant box and what? The label is followed by, so the previous two things are labels. And dash, go to the label, remove the lens with the given label. It's in the box. Then if it's equal sign, you'll be followed by a number, focal length, that need to go in the box. A sequence of letters. What letters? Okay. I need to see some example. Number equal to the focal length. Be sure to use a label marker to mark the lens with a label. What? Okay. What is going on? Replace the old lens with a new lens. Move the old lens. Put add a lens. Immediately behind any lens. Don't move any other lens. Da da da. Okay. So RN1 means what? Box 0, we put in RN1. After CM1 minus CM2, why is this in box 0? That's not so sure. Okay. QP minus, PC4, go to box 3. How do we know which box? If the operation character is a dash, each that begins with a sequence of letters that indicates the label of the lens which a step operates. The results of running the hash on the label indicate the correct box for that step. Okay, so we're gonna run CM. Let me just check what the heck is happening here, right? Let's just check what is CM. Box 0. Ah, I see. So minus means what? Minus means remove the lens of the given label. Okay, so we're gonna go in here, go to box 0, and say, hey, is there any right? And what about equal sign? Because many letters, labels can have the same numeric label. Got it. Okay. Oh God, there's more. Okay, so we're gonna do all of this. Alternatives are always present on the box in any lens. Lens or this from the back, each lens. To confirm that all lenses are installed correctly, add up the focusing power. All these lenses, the focusing power of a single lens. Okay, we can focus on that later. Let's focus on how to rebuild this installation. That took forever to understand. Not good for me. So let's see here. Okay. So first we're gonna read through all of them. Okay, we're gonna need a map. So let's call box is equal to a new map object. All right, and do I want to initialize all of them? Yeah, why not? Let's just initialize it. All 256 boxes. Okay. Let's do this. Set I to be this. Okay. So now we have this, right? All the boxes. All right. And so my data is gonna give us some instruction on how to put any of these things in. Okay. So let's just let entry E of data. I'm going to build this thing first. Okay. So first we're going to decide if it's equal sign or subtraction sign. Okay. So if E that includes subtraction sign, then we'll do something. Else we do something. see we did this correctly. Okay. So now what do we do with an inclusion, right? So let's we need to know what box that we're going into, right? So this is gonna be like that. And we're gonna hash this puppy. That's gonna be a number. Just see. I need to turn some of these off. Using me. Okay, so 0 and 3. Right? So we know the box number to go to. And then what do you want to do? Go to the box. And we're going to remove any entry. So we need a pop. Oh, how does remove do? How does remove work? Move is gonna move any remaining forward. Okay, so we're gonna go forward. So basically we're gonna need to do some sort of popping action. So we do a popping. Okay, so I don't really know. Let's do how do I do this? So is there something like this? Can I do pop and then a location like this? Pop C1. No, that doesn't do anything. Okay. Well, I guess slide. I could always slide, of course. But I would like to never do that. So is there a way to do that? Script. Right. Okay. Pop is always the last one. Shift is what I want. I think. Shift removes the oh no, shift is removing first. Slice. Do I want to have what about splice? In place. Okay, so how does this work? Start, delete count. Oh, so we can do slice. So if I do feed us splice at 1, 1, delete count 1, what is V now? Okay, that does it for one splice. Okay. So what we want to do is we're gonna need to find if there's an index, an entry in this box that has a B. Okay. So what we're gonna do, we're gonna just query, you know, just do it. The X in the key value pair. Okay. E. Okay. Length. Parts. Yes. So now we're at. It's gonna be an array. If. And let's just give this a name. Okay. Let's give this. Let's give this name. If um, I um, 0 equal um, e plus y 0 plus 1. If that is the case, we're going to need to do something. Oh, this is going to be tricky because this is going to keep on messing things up, right? That we break. Yeah. There's only one in this. There's only one. So yeah. Okay, anyways. B dot splice that we learned at the ith location removing 1. Okay. Let's break out of this loop. All right. And then we're done with this negation operation. Right? Is that right? Okay, now if it's an equal sign, we go to that box, I'm adding this thing. If it's present, we replace what? Replace the old lens with a new lens. Okay, got it. So now, the B number equals well, so first of all, is it always going to be minus like that? All right. Well, I don't know how many numbers are before equal sign, right? So a e dot split equal sign, choose the first bit. Okay, that's our B number. And now we're gonna go to box B and try to add in this thing. Now to add this in, yeah, let's call this V. Yeah. Does it have the label? So what I'm going to do? Okay. Did we not do something? Okay. Okay. I did it. Going to do this. They're gonna sign. Huh? Oh no. There we go. What? Oh, I see. RM1, CM2, OT7AB5, PC6. Okay, great, we got that, silliness. Now, what in the heck are we going to do? Focus on all the lenses. So when I add all the focus on a lens, how do we do that? The focus for a single lens, 1 plus the box number of the lens in question, the slot number what? 1 plus the box number okay, so now that we have this box, what do you want to do? Create iterator of dot values, right? This is the implementation task. So the box number right now is I. And this is gonna give me this. number plus 1 times the slot position, which is E plus 1 times the focal length, which is BS E1 parse end. Okay, so that will go through all of this, and we add them up. And this 145. So we change this to our inputs. Is that all? Okay. Well, that took way too long. That took way too long. How do I go back? Yeah, just need to read this very carefully. This was kind of confusing to me, but yeah, it kind of makes sense after making sense. And we'll get this interesting nonsense. Here's the hash map, shall we say. Kind of interesting. Yeah. Now we can, of course, write this all more functionally, which let's try to do. Okay. So how do we make this more functional? Yeah, so this is the implementation task, basically. Yeah. But let's okay, so we have all these for loops, and yeah, the only array approved method is right here. Right, this one. Okay, so let's make it better. Okay, so let's grab all of this that I want. Okay, bunch of things I don't need. Okay. So let's work on our sample. Now first we clean up our data. Okay. So our data, oops. Look at this. Okay. So first we're gonna have a hash function, which is this A right here. This A for hash function. And it works, right? Bigger. Okay, so the hash function works. We know it does. And then what we want for part A was we wanted to find a bunch of hash values, right? So that's basically this one right here. That's part. This gives us part 1, basically. So part 1 of the answer is really equal to we take data and we reduce it. We sum them up, right? And so that's the sample right here. Okay. Yeah, so Now, this is part one. Okay. I could also say that, okay, part one eats in data. Then, okay. Okay, great. So this solves part one. Part two, we got this box nonsense. So let's take so we're gonna first populate this box. Okay, with a bunch of things, right? So let's call this function b. Okay. We need a populate or install the lens function. Let's call this b. And what do we want? We're going to take in our data and take in a box, right? And we want to return this populated box, basically. So we want to spit out the populated box. Okay. M and box B. Okay. And we want to return a populated box. That's the idea. So what is it that we did? We initialize all the boxes. Now this step is unnecessary. I don't think so. It's nice. It's nice, but it's not necessary. It's nice, but it's not necessary. But okay. It's nice, but it's not necessary. We could, because how does this map object work? Did I use this? Do I need the sequential order here? I use an iterator. So here I iterate this box. And what's nice is that this index matches this iterator order. Now, if this box.value tells me more than just the value, if it tells me the key value, so can the iterator tell me the key or no, right? So I need to know what does this values do in map, right? Okay. So is it possible for me to get the key value? Keys. I can have an iterator key. I can have iterator keys and iterator value. Fine, we can do both. Okay, so we could set an iterator of both things, which is Interesting, to say the least. Okay, so if I can iterate, I don't think I need to do that. Okay, so then what is it I want to do then? For each key, well, M is going to be an array of those strings. So each of them I want to do something. So I'm basically doing a reduction. So I'm going to do a reduction to what, right? So accumulator values of key. What is my initial thing? Well, my initial thing should be this. What am I passing, right? I'm passing along my initialize empty box, right? Because I'm doing something to that. So my accumulator is gonna be this box. Okay. So then what happens here? Well, first thing we ask is a value. Does the value include the subtraction symbol? Now, if so, we're going to do something. If else, we're going to do something. Okay. So if it does include the subtraction symbol, we're going to go to that box and splice it out. Great. Okay. So this is the label. Label. If it has a minus sign, no, this is not the label. The label is this. And this is the box number. Let's do this for now so we don't confuse ourselves, right? Okay, let's don't be crazy here. And check this box number. To see if there's a key there. So check the accumulator. Has key there. If so, we're gonna do something. If not, then we will just gonna set this box number with the value bracket um, okay. But if we do, now we're gonna do something. If we do, we're gonna go find to see so then what we need is in this box, we need to find, because we know it has it. Well, it has the box of this number. We need to find if this box contains a label, length of this label. So you're gonna go reduce. And well, actually, if this box doesn't exist, we don't need to do anything. It's not right. Add it. We're taking away things. So I'm gonna go reduce. And I'm gonna try to find which one right. You should which one of this hey does y 0 equal label? Do I have label? Right. If so, if so, It has a label, the accumulator is gonna splice it out. If not, just return the accumulator. Okay, I think that's that, right? But I forgot. A has this. Okay. And so what we want to do then is now return this. Okay. I think that sounds right. It's complaining this column. And colon here. Oh, wait, hold on. If A does not, okay, I see. So here, I think that's right. This logic is kind of complicated. Okay. Now, um, now we're gonna check. Let's have it. If it, so we're gonna call reduce account. Um, if it has the box, Let's just see if this even works. And it works, right? It's so mind bending. Okay. Um, so if it has the box, I need to use reduce. First, I need to check if my thing is in it. Okay, yeah, let's just do that. Okay, so here we go. Okay, are you ready? So a dot get box num dot reduce, right? Of course, our favorite function. And first, I'm going to loop through just to see if we have it. Okay, so the accumulator being a Boolean. I want to get a Boolean out of this. So initially, I want to set it to be false. Okay. And as I am iterating, oh, why don't I also find the index? So let's say that this iterator is -1. Okay. It's going through, it's going through, it's going through. So I say, hey, here's the value of length, the label, is the label, is the label equal to the label? Apparently. Well, if it is, if there is such a label, then the accumulator equal to the maximum of the index and the accumulator. Because there's only a most one. I hope I did that correctly. If not, oh, and I need to, oh, so I just returned that. Okay. Not returned the accumulator. Okay, so now this is a number. Now, okay, now this is a number. Now we're going to ask, is this number positive or not -1? So if so, we need to update the length. It just actually works. Okay. Wait, where was it? If it's not, we repent. I feel like this is not gonna be a signing detail. Well, I hope it is. Okay. So after we run this, we get this. Is this what we're supposed to see for the thingamajig? RM1, CM2, OT7, AB5, PC6. Oh my God. All right. So I think this worked. So here's B in a functional array way. With ternary ifs. And awesome, but almost impossible to understand. Okay, let's just clean this up a little bit. You know, there's a comma here, right? Goes with this guy. I don't even know what level this should be. Let's say over there. Okay, so the install B function. Now what do we want to do? I want to make this calculation. Now this we need a double iterator. We need to iterate. Actually, can we put the length of a box? What about the size? We can get the size, which is nice because that's we know how many iterations we need to do. Okay. So for part 2, the solution. First of all, let's just see if this actually give us the right answer. Just check, right? So I already have a box right here. So we're gonna let box check our work equal to this, equal to our input file, right? Now it's interesting that it's printing. I'm not sure why. Oh, it's printing the data. No need to do that. So this populates our box. Let's use our previous solution here to see if we get the right answer. Uh-oh. So right, we want to do something else. Okay. Here are these two iterators. I less than the box of size. Okay, let BS to be the next value. Let KS to be the next value. And instead of I do KS. Okay, this number is that is the right answer. Okay, so this horrible thing worked. This horrible thing worked. Okay, so this horrible thing worked. That's awesome. Oh my god, this is such a mind bender just to go through this. Like this is look at this. This is this. This logic right here. It is this thing, which ostensibly, yeah, I mean, good luck understanding that. I mean, you have to parse. Oh, this is gonna take some effort to understand. But right now, at least our answer is correct. So now I just need to package this into thingamajigger. Okay, well, that's not that bad then. So our part 2, our answer, okay, our part 2, our answer is going to take in the box. Well, yeah, and then I'm going to create two iterators, R and K, and just go through this silly calculation. And then we do a reduction. So first we initialize this. So, okay, and what is to be returned? Can I iterate over, let's see, the array 5, right? And if can I do map here? Let's go map to 1. No. Go to F. Now can I map? So empty is different than undefined. What does that mean? I don't know, really. Not an expert, really, to be honest. But we will do array b dot size dot fill, which can be iterated over, which we want to reduce. And what are we reducing? Um, hmm, okay, system here. Okay, well, we're gonna have x, y, z. It's gonna be double reduced. The initial value of the function is 0. Okay. And I'll run out of letters. accumulator plus PS plus 1 times E is the value of the index. I think that works. Okay, so this is the answer with this method right here, right? So I'm gonna turn this off. Turn off all of this. So right now, there's nothing to print, right? So what we're gonna do is we're gonna print P2 of the box. And if we do it correctly, it should be this number, 25. Is it equal to this number? Oh crap. So what's wrong? All calm down here. Initial value is 0. Oh, this one. Oops. That's not a number I want to see. Okay, hold on. This reduction should be doing something. Oh, wait a second, 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 calm down. This is good like that. Okay. This is good. That's I don't want it there. This. Okay. There we go. Is it this number? 25933. Yep. So here we go. We did it. This is a P2 function. And the answer, we just need to feed this int. My goodness. Well, that was fun. Let's see. So if we were to remove all the white space, the logically helpful things, which is the original formatting, we would remove all that. This P2. That better? Well, it's minor expand, shall we say that? Okay. B. One solution function. Two solution function P2 takes into installed boxes. The lens installed boxes. So there we go. There we go. So part one. Let's do a data, I think. Okay. I'll use this. Oh, P1 of data. There. Right. 5091. Yep, that's my answer. So P2, okay, so here's what we can do, right? All the places with the B, we could replace with this right here. So I want to do that. Where are the B's? B, B, B. Well, we do this. Function evaluated B M comma map, and then this turn into M like that. So now this just needs to take data. Oh crap. Oh, I'm just missing. Okay. Well, there we go. That's is life better? That's that. Of course, if I turn on, let's turn this console log. Okay, and so this answer should be this. This answer should be this, at least for mine, right? 50916725933. Yup. So if I were to turn on, if I let the stream be also replace, let's replace everything. If I let the stream be document.body.intertext, and it should just work on our inputs. So here, I go here, I paste it, and if I enter, there we go. All right. That's the functional way of doing it. Yeah, mind that. All right. Let's stop here.